Alright, this is Unit C, Coordinate Geometry Day 1. Make sure you have the 1B notes open. The regular 1 notes are a little bit different. Here's our title page, and this is information that we've already pretty well gone through, but just real briefly. Slope is rise over run. Over y minus y over x minus x. As always, make sure that these first two come from the same ordered pair and the second two come from the same ordered pair. That's what those subscripts mean. Oh, lovely y that is. Positive slope is a slope that goes up from left to right. A negative slope goes down from left to right. A zero slope is a horizontal line, and undefined is a vertical line. All review from Algebra 1. Find the slope between 2 points. Then determine what the line would look like when graphed and sketch an example. We may just find the slope. So we've got y minus y over x minus x. So I'm going to do 1 minus 3 over 0 minus 3 is negative 2 over negative 3, which is 2/3. This would slope upward from left to right, a little more gently than a slope of 1. If I'm going too fast, then you can pause. But this is review. We should be able to go through this pretty quick. Slope is y minus y over x minus x. And that's supposed to be a parentheses. So I use negative 9 first. I need to use 8 first. Minus a negative is plus a positive. Negative 9 plus 5 would give us negative 4 over 11. This would be sloping downward. Alright, example C. Y minus y over x minus x. So 2 minus 2 over negative 2 minus 4. The top is 0, so it's a 0 slope. This would be a horizontal line. And y minus y over x minus x, 3 minus 10 over negative 1 minus negative 1. And the bottom is 0, so this is an undefined or no slope. Undefined is what those hieroglyphics are saying. Beautiful. Alright, next page. Determine the slope of the line from the graph. We've actually already done this quite a few times. Let's just do one of these. And the numbers are a little blurry, but I think we can figure it out. So this is a 2, and this is a 3. This is a 4 over here. But it's a 6. 1, 2, 3, 4, 5, 6. So the rise is from 3 to 6. That's a rise of 3. The run is from 2 to 4. That's a run of 2. It's positive. It's sloping upwards. So that is a slope of 3 over 2. Being able to count the slope is important for graphing those quadrilaterals that we've been doing lately. This one, B, would be a negative slope. You can do that on your own if you want. Alright, so this is a little bit different. This is something new. We're going to partition a segment. So partition means to separate or divide. A line segment with endpoints A and B can be partitioned by another point into a given ratio. One partition we're familiar with is the midpoint. So if a segment is divided with its midpoint, it's partitioned to a 1-to-1 ratio or 2 equal parts. If If a segment is divided into a 1:2 ratio, it could be thought of as split into thirds. So what we're going to start to notice here is that 1 plus 2 gives us 3. So a ratio of 1:2 is actually talking about thirds, with 1/3 on the left, 2/3 on the right. So we see down here, when we talk about a 3:2 ratio, we're really splitting it into fifths. So when you turn a ratio into a fraction, you need to add those two to get the denominator. In a 3:2 ratio, we would have 3/5 first and 2/5 second. It's really not left and right. That's just to help you kind of get an idea of how it goes. Partitions are set up with whatever letter is presented first. So partition from on segment AB, the 2 goes with the A, the 3 goes with the B. So a ratio of 2/3 again is in fifths, with this portion being 2/5 and this portion here being 3/5. So the 2 to 3 is just the numerator of the fraction. Similarly, down here, if we have segment AB partitioned into a ratio of 5:2, we're really talking about sevenths. And this first part is 5/7 of the way, and the second part is 2/7 of the way. And we're going to learn a formula. I think it's best with a formula. There's other ways to do this. If you don't like the formula, I can show you the logic way to do it. But the formula is relatively straightforward. So for the x-coordinate, if the ratio is m to n, again, I'm sorry if I'm going too fast. You can always pause and get caught up. If the ratio is m to n, that is terrible. Sorry, my handwriting is terrible. M to n, for our x-coordinate, we actually take x2, and that gets multiplied by m, so the second coordinate times the first part of the ratio, plus the first coordinate times the second part of the ratio. So this is kind of a reverse. And then we add the two parts together. So like how we said it was split into fifths or sevenths or something like that, this is, that goes on the bottom. That's an n, not a 2, sorry. And then the y's are very similar. For the y's, it's just going to be m y2 plus n y1 all over m plus n. And that's the y-coordinate. So the formulas that I have written up here, you just have to know that that denominator is kind of a big, red is a big fraction bar. So similarly, when we have the formula for the y-coordinates, that denominator is under a big fraction bar there. Alright, let's look to see what we have here. Again, it's a little bit fuzzy. Let's zoom in and see if we can figure this out. So it looks like the coordinates at P are 1, 2, 3, 4, 5 in the X, and 1, 2, 3, 4 in the Y. Our coordinates for Q are 9 in the X, and 4, 5, 6 in the Y. And then we're going to use our formula here. So we'll come back in a little space. To partition it in a 2 to 3, it says a 2 to 3 ratio. 2 to 3. The 2 is our m. The 3 is the n. So when I take my x-coordinates, I'm going to do m times the second x-coordinate, which is 9, m times, let's write it, yeah, m times x2 plus n times x1 all over m plus n. And I'm going to put M in here, N in there. X2 comes from all the way over here, and X1 comes from all the way over here. So let's try it. 2, whoops, that's not it. 2 times 9 plus 3 times 5 over 2 plus 3. It's going to be 18 plus 15 over 5, which is 33/5, which is 6.6. If you look on your graph, 6.6 is about right here. It looks like that might be a 2 to 3 ratio there. Okay, so that's your X. Let's try the Y. I'm not going to write the formula this time. I'm just going to go to the plugin. So our Y is M, which is 2, times your second Y coordinate, which is 6, plus N, which is 3, times your first Y coordinate, which is 4, all over the 2 plus 3 again. So that's 12 plus 12, which is 24 over 5, which is 4.8. So we go back up to the original problem and we see they want a point called R at that partition spot. So R is going to be 6.6, comma 4.8. And if you look on the graph, 6.6 lines pretty well up with 4.8, right around in there. Pretty neat. Okay, we're going to do a few more of these. Here's the work if you need to pause, come back and work through it. Alright, moving on. We're going to partition in a 3 to 2. To go through this quick, I'm about to hit my limit. So this is 3, 4, and this one is 6, 10. The X coordinate, M is 3, N is 2. It says the line segment AB. So A goes with the first. A is your X1 and B is your X2. So the X coordinate is going to be M, which is 3, times your X2, which is 6, X2, X1, plus N, which is 2, times your X1, which is 3, all over 2 plus 3. So 3 times 6 is 18, plus 6 is 24 over 5, which is 4.8. The Y, again, it says segment AB, so A is the first, so Y1 is with A, Y2 is with B, and the Y is M times Y2, which is 10, plus N times Y1, which is 4, all over 5. 30 plus 8 is 38 over 5, which is 7.6. So our ordered pair is going to be 4.8, comma 7.6, and that is the point that will partition it. That's our point P, I think, according to the problem. Point P. Alright, looks like I'm out of time. I'll continue on the second video.